Hello everybody, this is Sandhya Rani. In this video, I would like to discuss about Newton's backward formula. Okay, so let us see what is Newton's backward formula. So this, before learning about this Newton's backward formula, let us try to recap what is this backward difference table. Okay, so backward difference table, let us try to understand here. Let us take simple example now. Whenever x value and y values are provided like this, 0, 1, 2, 3. The respective y values are 4, 5, 9, and 10. Okay, so backward difference operator is denoted with nabla. How it is denoted as nabla. Reverse triangle, and it is called as nabla. So next, let us try to find out the differences. As we have discussed in finite difference video, backward difference table and what are backward difference operators we have discussed. The same thing, let us try to recap once here. First backward difference operator is nabla y. The second one is nabla square y. And next one is nabla cube y. And next one is nabla power 4 y, and so on. Depending upon the requirement of the values, we need to consider the sufficient backward different operators. So the given information is considered as x0, this one, x1, x2, x3. The corresponding y values are y0, y1, y2, y3. Okay, so the first for backward differences, that is nabla y1, nabla y2, nabla y3. Okay, second backward differences are nabla square y2, nabla square y3, and cubic are third, that is nabla cube y3. So let us try to find out the differences here. Y1 minus y0, 1. And next y2 minus y1, 4. Y3 minus y2, 1. So next delta y2 minus delta y1 is delta square y2. That is nothing but 3. Delta cube by delta y3 minus delta y, sorry, not delta, nabla. Nabla y3 minus nabla y2 is minus 3. That is 1 minus 4. Next, nabla square y3 minus nabla square y2 is minus 6. So that is nothing but nabla cube y3. So therefore, after getting this first backward differences nabla y1, nabla y2, nabla 3, and second backward differences nabla square y2, nabla square y3, and third backward differences nabla cube y3, let us identify the simple point here. All the bottom ones usually y3, nabla y3, nabla square y3, nabla cube y3. The bottom ones are all same, right? So therefore, these terms will be utilized in our formula. Nabla, nabla square, nabla cube and all. Nabla yn, nabla square yn, nabla cube yn, and so on. Okay, and what does this n mean? N mean n is equals to x minus xn divided by h. Where this xn is the last value of our x. It means in this question, in this table, x3. And x is nothing but the value of x where we are finding its corresponding y, and h is nothing but the common difference between all successive x values, right? So depending upon all this now, first let us try to understand what is Newton's backward formula. So yn plus n divided by 1 factorial into nabla y n, isn't it? Here n into n plus 1 divided by 2 factorial into nabla square yn, okay, plus n into n plus 1. You include one more extra term. Here n into n plus 1 is there. No? Here n plus 2, one more extra term will be coming, divided by 3 factorial into nabla cube yn. Next term will be what? N into n plus 1 into n plus 2 into n plus 4 divided by 4 factorial into nabla power 4 yn. Okay, so like this we need to memorize our Newton's backward formula. After this, let us see one example. This is the derivation actually. And next, if you see the example, the given x and y values are x0, x1, x2, x3. This is y0, y1, y2, y3. Okay. This is nabla y1, nabla y2, nabla y3, nabla square y1, nabla square y3, y2. And this is nabla cube y3. Okay. So, and if you observe all ending values of all the column like y3, y3, nabla square y3, and nabla cube y3. These are the required values that to be substituted in our Newton's backward interpolation formula. So before that, let us identify what is h. H is nothing but the difference between two successive h values. So 1 minus 0 is 1. So h can be considered as 1. Okay. And last x value is x3. That is 3. So therefore, n is equals to x minus xn divided by h. Okay. N is equals to x minus xn divided by h. So therefore, n is equals to what they're asking us to find out f of 2.8. So x becomes 2.8 minus 3 divided by 1. So which implies n is equals to minus 0.2. So we got n value and we are having all required values like nabla y3, nabla square y3, nabla cube y3. All are there. So let us substitute all in our backward formula, and if we calculate with the calculator, we are going to have the value as 27.992. That is a required y of 2.8 value. That is 27.992. Okay. So to find out f of 2.8, and this 2.8 falls the second half. Okay, second half. So we need to pick Newton's backward formula to calculate this f of 2.8. So what is the working procedure we have utilized here? First, we try to calculate what is n value, what is h value. And we have generated backward difference table. From the backward difference table, we need to guess the values. What is y3, nabla y3, nabla square y3, and nabla cube y3. And let us write the formula and put all these values in our formula. And by using calculator and by substituting and calculating, we are going to have its respective final answer as 27.992, which is nothing but y of 2.8. So in this way, we are supposed to utilize Newton's backward formula. Right? So with this, what we have done is we did with the Newton's backward formula.